Hey everyone. So you've probably already seen videos of people modify microtransformers to make spot welders. I mean, it's pretty simple. You just cut the secondary out and rewire it, maybe like 2 or 4 turns of large cable, like 4/0 or some 2/0 cable. But the issue is that you're limited by essentially what the transformer core can take. And it's usually pretty rare that you'll get anything above 1500 watts. I mean, you can get large current, like I've personally gotten up to 800 amps from such a mod, but today we're gonna be stepping up a bit. So this is an old charger, 24 volt, 24 volt output. As you can see, the secondary has already been removed, and what's nice about it is that we have a nice space in it, and the core should be good to give us an easy 2 to 3 kilowatts. I have some nice, got some nice cable, some 4/0 that I picked up a while back, and we're basically gonna be running 2 runs in parallel. Hopefully, should be able to get at least 2000 amps out of this bad boy. So this transformer, since it's a charger, you have multiple power levels. So basically what we're going to want to do is that this is a 120 volts nominal. So that means you can put 120 volts in the shortest primary turns. So that means if you go to the outer turns, you can easily get up to 180 volts on those. And I personally ran this transformer at 240 volts and it still hadn't saturated, which is kind of ridiculous. I mean, microtransformers literally run under saturation, like they pull like 6 amps with no output load on them. So at 240 volts, and as you can see, there's at least 14 gauge on the primary side. So yeah, we're gonna get a couple kilowatts out of this bad boy. So one thing that's important when you're running wires in parallel, you want to make sure that they're both as similar as possible in lengths, because if not, you'll end up with one with a high resistance, and the other one will essentially end up carrying most of the current. So you can see here, they're pretty damn similar in length. Maybe a couple millimeters difference, but for our application, it should be fine. Alright, so we've now got about 2 turns on each side, so 4 turns total. Yeah, as you can see, large cables, they're always a bit of a pain in the ass to fit, especially around a tight radius like a transformer core. Alright, so now we're done winding this bad boy up. So we're pretty much ready to plug it in and start melting stuff. Now, we could go directly lugs on whatever we want to melt, but these are kind of nice cables and I don't really want to mess them up, so I'm going to be putting some aluminum squares basically between the workpiece and what we're going to be melting. So this will dissipate hopefully enough heat from the wires so that they don't heat up, while not dissipating too much from whatever it is we're trying to melt. So we'll see if it works or not. We might just go directly with the lugs, but hopefully not. So unfortunately, I haven't used this in a while, so I can't remember which wires we should use. However, what I do know is that any combination between these 2 distribution blocks can take 120 volts. So essentially what we're going to do is we're going to put 120 volts and see which other will give us the highest voltage, because the internal impedance is just too low for my multimeter to be able to read, because normally we want essentially the one with the highest impedance to put our 240 volts on. Alright, so we're now putting in 50 volts AC, as you can see here. And if I change my probing, now we're at to 50 volts, 0.7, here 54 volts. Unfortunately, my initial assumption was wrong. We shift over again, 58, 62, 66. Over here we're at 70 volts. So these 2 have the highest voltage, so essentially gonna be red wire and this innermost one. Alright, so let's switch out the wires. Now you can see we have 50 volts on our 2 connector wires, and if we go over to the other extremes, they are at 32 volts. So now we have we've got the right taps. Essentially now time to crank it up to 240 volts. So to power this thing, I'm going to be using my 240 volt variac setup. So it's just power stat, 240 volts. And over on this side, we have a nice 15 kilowatt isolation transformer. So if you know how variacs work, and here in North America, we run on two 120 volt phases. It means that the common is actually on 120 volts and not neutral. So this allows us to switch between whether we want the reference to be either line 1 center tap or line 2. So really useful. You can see you have a nice little watt meter. Unfortunately, the amp meter is busted, and analog voltmeter and output control. Alright, so that's 240, and as you can see, we're only at 0.7 amps, no load. So core is on the verge of saturating, but still not quite. So let's go check the output voltage. So 3.7 volts on the output, so that's perfect. As you can hear, it's making quite a bit of noise, but that's because it's an old laminated transformer.
mes mains vont se réchauffer.
Hey, ça boucane.
Ah!
En tout cas, tu vas en avoir à respirer des bonnes affaires. Prochaine fois que des gars, ils vont aller chez le médecin, tu veux combien de cigarettes dans le Là, je fume pas. Ah, vous avez des drôles de passer. Je fume pas, mais j'ai smoké un Westcott l'autre fois.